program that is running on an end system is called a process. When processes that are running on the same host need to communicate with each other, they can use inter-process communication mechanisms that are defined by the operating system on that host. For example, using message passing or shared memory. Two processes running on different hosts, though, should communicate with each other through a network. This is made possible using a software interface called a socket. A socket to a process is like a door to a house. A sending process sends messages out of its door through the network to the receiving process. A receiving process receives messages at its door coming from the network. In order to send a package to someone's house, you need their address, the destination address. An IP address, which is a unique 32-bit identifier we will further explore in the network layer discussions, identifies the end system in the network. However, is that enough for addressing among processes? Let's compare it this way. If you live in a large high-rise building with many apartments, is the building's street address enough for your friend to send a package to you? No. They will need to provide your apartment number or street number as well. To address processes within an end system, something named a port is used. For example, if you want to send a web request to cs.sfu.ca, the IP address of the SFU web server is 142.58.102.68, and the port address used for this communication will be port 80, which is a port used for web servers. Now remember our discussions about protocols. A protocol defines type of messages, message syntax and semantics, and what happens in message sent and receipt. Application layer protocols define these details for an application layer communication among the processes. And like any other protocol, they can be open or proprietary. HTTP and SMTP are examples of open application layer protocols we will review shortly. Skype is an example of a proprietary protocol we will briefly discuss shortly.